In this video, let's try another application of trig functions. And for this example, for part A, let's find the linearization of the function f of x, which is cos x, and let's do that at the point x equal pi over 6. So to get started with this question, we should remember the linearization formula, and that says that f of x is approximately f of a plus f prime of a times x minus a. So this formula, either called the linearization formula, or depending on the context, sometimes it's called the linear approximation formula. So I think of this as saying f of x is pretty much f of a plus a little bit of error. And if we think back to the earlier video on error, we might remember that error is always represented as a derivative times a small change in x values. And that's a good way of thinking about this formula. So our approximation here will be pretty good as long as this change in x values here is fairly small. Now, to get started on plugging in, first of all, the a here in this formula represents a constant, and in this case, it is the x value that's given in the problem. So a equal pi over 6, that's our given x value. The function that we're working with in this problem, well, we were told it was cos x. And to plug into our formula, we'll also need to find f prime of x. So thinking back to our trig functions, the derivative of cos x is negative sine x. So the values that we'll need for this problem, we'll have to find f of a and f prime of a so that we can plug into our formula. Well, f of a is cos of our given x value, so cos of pi over 6. Let's draw our special triangle. So we need a right triangle with angles pi over 3 and pi over 6. And our side lengths will be 1, root 3, and 2. And we can think back to SOHCAHTOA, which reminds us that cos of an angle is going to be the adjacent over the hypotenuse. So if we grab our angle pi over 6 here, cos of pi over 6 is going to be root 3 over 2. To get our value of f prime of a, well, we figured out that our derivative was minus sine x. So we're going to plug in our a value, the given x value in the problem, and we need sine or negative sine of pi over 6. So we're going to have a negative value here. And thinking back to SOHCAHTOA, sine is going to be opposite over hypotenuse. So looking at our angle pi over 6 here, its sine value is going to be 1 over 2. So just a half. And f prime of a comes out to minus 1/2. So now we're all set to plug into our formula. What we are getting here is a linearization of cos x. So we're saying cos x is approximately f of a. So it's going to be pretty much root 3 over 2 plus a little bit of error. And that error looks like our derivative. So f prime of a times x minus a. So x minus pi over 6 gets multiplied on there. So just a caution when you're writing down a linearization formula, that a is a constant, so you will have the a values replaced with some number that's given in the problem, but x is a variable. So the x's are just going to stay as x's in this formula. If you want, we could rewrite this just a little bit more simply. We could say cos x is approximately root 3 over 2, and then just write minus 1/2 times x minus pi over 6. So that is part A completed. For part B, let's check our answer. So let's check the linearization by estimating. Let's try estimating cos of pi over 7. Well, pi over 7 is not one of our special angles. So cos of pi over 7 is not a value that we would know off the top of our heads. But pi over 7 is pretty close to our a value of pi over 6. So if we try evaluating cos pi over 7 using this formula, that will be a good way of checking the linearization. We'll see if we get a decent answer here. So all we have to do is plug in x equal pi over 7, and we'll check both sides of this approximation on our calculator. So on the left side, we've got cos of pi over 7. We'll check that value in a minute, and we're going to compare that to root 3 over 2 minus 1/2 times pi over 7 minus pi over 6. And we'll also check this value on our calculator. So if the two answers come out reasonably close, then that will give us some indication that our linearization was probably done correctly. So from our calculator, you can double check these values. For the left side, we'll need to make sure that our calculator is in radian mode. But if we do that, we get a value of about 0.901. And for the right side, using our calculator, we get a value of about 0.903. Information is pretty good.